So we are the EC's sixth semester students, and we have been given the, according to our syllabus, we have been asked to explain the data pointer, program counter, and stack pointer for the 8051 microcontroller. Our teammate is Kuldeep, Jitendra, Mukesh, Nitish, Pallavi, and Ankur.
Let me start from data pointer. The data pointer is the 8051's only user accessible 16-bit 2-byte register. Data pointer, as the name suggests, is used to point to data. It is used by a number of commands which allow the 8051 to access external memory. When the 8051 accesses external memory, it will access external memory at the address indicated by the data pointer. Here, this is a 16-bit data pointer, data pointer, in which is divided into 2 bytes. Data pointer with lower bit name, and second one is data pointer with higher bit name.
Now let's see an application in case of the lookup table for the square of a number. Here we are going to use the data pointer to fetch the square of a number, which will be read at the port 1. So as you can see from the program, the table is initialized and it contains all the square of the numbers from 0 to 9, and P1 has been configured as an input port. Now in the loop, you can see we are going to read the input from the port 1 and transfer it to the accumulator A. Next we are going to fetch the corresponding square from the lookup square table. How it does is that when the A, let's take an example, if A is 2, it adds 2 to the DPTR and the corresponding value is 4, and now this value 4 is stored in the accumulator A, and in the next step the value 4 stored in the A is transferred to the P2 port, which is the output port, and we configure this loop to be infinite, meaning that the input is read from the P1 and correspondingly the output is put at port P2.
Next, program counter.
Now we come to the point program counter. Program counter is a 2-byte address which tells the 8051 where the next instruction to execute is found in memory. When the 8051 is initialized, PC always starts at 0 address and is incremented each time an instruction is executed. It is important to note that PC isn't always incremented by 1. PC means program counter. Since some instructions require 2 or 3 bytes, the program counter will be incremented by 2 or 3 in these cases. The program counter is special in that there is no way to directly modify its value. That is to say, you can't do something like program counter equal to 2430H. On the other hand, if you execute long jump 2430H, you have effectively accomplished the same thing.
Now in this program, as we can see that when each of the instruction is executed, the program counter points to the next address. It happens for each of the instruction up till the number 6 instructions. For the last instruction, which is the S jump here, the program counter stores the value of the ROM address 00A since it is an infinite loop, and it keeps on repeatedly storing the same value.
Now stack pointer. The stack pointer may hold an 8-bit 1-byte value. The stack pointer is used to indicate where the next value to be removed from the stack should be taken from. When you push a value onto the stack, the 8051 first increments the value of stack pointer and then stores the value at the resulting memory location. When you pop a value of the stack, the 8051 returns the value from the memory location indicated by the stack pointer and then decrements the value of stack pointer. This order of operation is important. When the 8051 is initialized, stack pointer will be initialized to 07H. If you immediately push a value onto the stack, the value will be stored in internal RAM address 08H. First, the 8051 will increment the value of stack pointer from 07H to 08H and then will store the pushed value at that memory address 08H. Stack pointer is modified directly by the 8051 by 6 instructions: push, pull, push, pop, a call, a lcall, return, and return I. It is also used intrinsically whenever an interrupt is triggered.
Now we will see an example for the stack pointer, how it really operates. Here we see that there are 3 move commands to write the immediate value in the respective registers R6, R1 and R4. Now we use 3 consecutive push instructions: push R6, push R1 and push R4. We know by default the stack pointer is configured at the memory location 07. When we use the first instruction, in push R6, we know R6 has a value 25. So what a stack pointer does, it first increments itself to 08 and places a value 25. Similarly, for the push R1, it increments the stack pointer to 09 and pushes a value 12 there. Now when we want the value to be returned from the stack, we will use a pop instruction, and it should be executed in the reverse order of the push. And what the pop will do, first it will pop out the value, and then it will decrement the stack pointer, and it will repeat for as many pop as they are in the program. So we have seen the working of the data pointer, stack pointer, and the program counter for the 8051. Thank you.
That's all.